When it comes to numbers and statistics, not all numbers are created equal. Knowing the level of measurement tells us the kind of data that we're working with and the types of statistics that we can do with that data. There are 4 levels of measurement: nominal, ordinal, interval, and ratio. These levels of measurement have a distinct pecking order. Nominal data is at the bottom of the chain of command, and ratio data is at the top. Ratio level data is the most complex and allows us the most flexibility in terms of what statistics can be performed using this type of data. Nominal level data, in comparison, is the least complex and allows for the least flexibility in terms of the statistics that we can use and perform using this type of data. Another word for nominal data is categorical data, meaning at this level of measurement, we're simply looking at how data can be sorted into different categories or groups. There's no hierarchy or order to the data. One group or category isn't better than or less than another. The classification system is completely arbitrary. This level of measurement simply tells you how many exist in a given category. For example, if the categories were types of fruits, it would tell you there are 2 apples and 1 pear in the bowl of fruit on the screen, but it can't tell you one is ranked higher than the other. And we can't calculate the mean or median because pears and apples are different and those numbers can't be put together. Nominal data gives us the ability to take a large amount of data and organize it into meaningful, although arbitrary, categories to help us make sense of the information. Nominal data is often collected and researched with human participants on demographic forms. Questions that are asking participants their gender, race, or marital status are all examples of nominal level data. One category isn't ranked higher than another, they're just qualitatively different. Ordinal level data is known for organizing data into a hierarchy or a ranking system. Although we cannot rank categories such as gender, for example, we can rank categories such as year in school into a hierarchy, with freshmen being at the bottom, followed by sophomores, then juniors, with seniors at the top. Another feature of ordinal level data is that there isn't a fixed numerical distance between the ranked categories. Examples of ordinal level data on a demographic form can include information such as class ranking or educational background. To better understand what I mean when I say there isn't a fixed numerical distance between these categories, let's look at finishing times of a Formula One race. At the 1988 Belgian Grand Prix, Ayrton Senna finished first with a time of 1 hour and 28 minutes. Prost came in second, 30 seconds behind him. Capelli came in third, 1 minute and 15 seconds behind Senna. Although Senna was ranked first, Prost second, and Capelli third, there wasn't an equal distance between each of their finishing times. This is why we can calculate the median when using ordinal level data, but we can't calculate more complex statistics such as the mean. Interval level data is also ranked. However, there is a fixed or equal distance between each value. Interval level data can include measurements of temperature, where there's an equal distance between each degree. It also includes variables that are commonly measured by psychologists, such as intelligence, depression, or anxiety. One factor that distinguishes interval level data from ratio level data is that there is no absolute zero. We can measure a construct such as intelligence, for example, but we can't say that someone has 0 intelligence. Psychologists commonly use Likert or Likert scales when measuring various constructs. The scale on the screen is the Center for Epidemiological Studies Depression Scale for Children. Take the first question. During the past week, I was bothered by things that usually don't bother me. Respondents have to rate how often this has happened to them over the past week. Not at all, a little, some, or a lot. Now, you could argue there isn't an equal distance between not at all and a little, since the difference is really subjective. However, in psychological research, we treat this type of data as interval and pretend that there is an equal distance between them. This means we can do things such as calculate a total score for the scale and calculate a mean, median, and mode. This allows us to run more complex statistical analyses that require the ability to calculate a mean, such as a t-test or an ANOVA. Ratio level data has all the qualities of the levels of measurements below it. It is ranked and it has a fixed or equal distance between the values. In addition, it has a true zero. For example, if you ask people to report their yearly income on a demographic form, someone can report 0 if they have no income at all. The true difference between interval and ratio scales comes from their ability to dip below 0. As discussed earlier, interval scales do not have a true zero, however, they can be negative. For example, temperature below 0 degrees, such as negative 10 degrees Fahrenheit. Ratio variables, on the other hand, never fall below 0. Variables such as height and weight and age are all ratio level variables, and they measure from 0 and above, but never fall below it. Ratio level data allows us to calculate a mean, median, and mode like interval level data. It also allows us to calculate a ratio due to the presence of a true zero, something that isn't possible with interval level data. Like interval level data, ratio level data allows us to run more complex statistical analyses. Determining what level of measurement a variable is not always clear-cut. Sometimes it depends on the way the question was asked and measured. For example, if we look at the questionnaire on the left, respondents were asked to type in their age in years in the blank space. This would make the resulting data ratio. Technically, there could be a true zero, there is an equal distance between each year, and the data can be ranked from youngest to oldest. However, look at how age was measured in the questionnaire on the right. Respondents were asked to mark which of the following groups best describes their age. The age groups are ranked from youngest to oldest, however, there's not a fixed or equal distance between each of them. In category A, it includes respondents 21 years and younger, a 20-year span of time, while category B includes respondents 21 to 25 years old, which is a 4-year span of time. There are varying distances between each of the categories or ranks, so while the resulting data can be considered ordinal because it's ranked, it can't be considered interval because there isn't an equal distance between each of those ranks. This slide just summarizes the type of statistics that can be calculated with each level of measurement. With nominal or categorical level data, we can only calculate the frequency. With ordinal level data, we can calculate the frequency, the median, and percentiles. With interval level data, we can calculate everything we can with ordinal level data. In addition, we can also calculate the mean and standard deviation. With ratio level data, we can calculate everything we can with interval level data, as well as calculate ratios. Let's walk through how to decide what level of measurement the data you're working with is. The first question you need to ask, do the numbers tell us a direction of difference? So for example, is one value ranked higher or lower than the other? If the answer is no, such as the case with demographic variables such as gender or race, then the type of data we're working with is nominal. If the answer is yes, we're going to move on to the next question. Is there an equal distance between each value? If there isn't an equal distance, then we're working with ordinal level data. If there is an equal distance between each value, then we need to ask ourselves the next question, is there a true zero? If the answer is yes, then we have ratio level data. If the answer is no, there is no true zero, then we have interval level data. In conclusion, there are 4 levels of measurement: nominal, ordinal, interval, and ratio. Nominal includes data that can be categorized. Ordinal includes data that can be ranked. Interval includes data that can be ranked and also has a meaningful distance between values. And then ratio includes data that can be ranked, has a meaningful distance, and a true zero.